Alright, hello, geometry. So we're almost through our first half of chapter 8. So I'm splitting up chapter 8 into 2 units. So this first unit is 8.1 to 8.4. So we've done 8.1, 8.2. We had our quiz. Now you guys had an assignment on 8.3 yesterday. I posted the solutions for that in the assignment. You learned 8.3. We're going to learn 8.4 actually in 2 parts. So we won't be done. Oh, sorry about that, guys. Probably can't see me now. You won't be done until, so you won't be done this unit until probably around next Wednesday. You'll have an assignment on 8.4 part 2. I'm going to call it this 8.4 part 1. This is going to be probably our hardest unit we've done in a little while. So I'll split it up into 2 parts. This stuff's really important. It's introduction to trigonometry, which you guys have not learned yet. It's called triangle trig. So anyway. So what's going to happen is we'll do 8.4 part 1, you'll have an assignment on this on Monday. Then 8.4 part 2, assignment on that on Wednesday. I'll take any questions in between that time, or anything we've learned so far, quiz, anything like that. Once after that, you're going to have a test, probably this Thursday or Friday. I might do a little poll on that, on 8.1 to 8.4. So that'll be the last grade of the quarter. So these couple homeworks and that test, they're the last grades of the quarter. The quarter ends April 3rd. I'm going to put that in my email, everything like that, probably next Monday. But yeah, so the quarter ends April 3rd, just so you guys all know. So hopefully you're happy with your grades at. If not, you have this last test to bring it up, as well as a couple homework grades if you missed a few homeworks in the beginning or whatever. Alright, so again, I'm splitting this up into 2 parts. So, I have plenty of time to talk about each one and keep the videos to a shorter length. Alright, so it's called trigonometry. So what is trigonometry? So it actually tells us. The word trigonometry comes from 2 Greek terms, trigon meaning triangle, and metron meaning measure. So trigonometry is triangle measure. It's all based on triangles, specifically right triangles. Everything we talk about in this section is going to be on right triangles, which is what we've been talking about most of the time in this whole unit. I'm going to be talking about that more as the rest of the chapter goes on, but we'll do that after the next test, probably in the 4th quarter. So a trigonometric ratio is a ratio of the lengths of 2 sides of a right triangle. So in this case, AC over AB is 1 trigonometric ratio, which we're going to talk about trigonometric ratios and how if you use the different things of trigonometry, how you find the different answers we're going to be finding. Okay, I'm just kind of defining those 2 terms. So then this just kind of says the trigonometric ratios, as long as each right triangle, as long as they have the same acute angle, so see how these all have an angle of 35, all the trigonometric ratios are going to be constant for the given measure, and all these triangles are similar by AA similarity, of course, because they have 90 and 35. Alright, so that's kind of what they're talking about in the beginning, but basically what I wanted to just read together this first part is just that trigonometry is triangle measure, just know what trigonometry is. And then trigonometric ratio is basically a ratio of the lengths of 2 sides of a right triangle. Again, all about right triangles, okay? Alright, so let's talk about these trigonometric ratios. I'm actually going to have a really cool tool for you guys to remember these, but let's just talk about them first, and then I'm going to give you the cool tool, kind of like a mnemonic to memorize them and really know them easily. It's something a lot of these kids learn. You've probably heard it before. Alright, so there's 3 types of trigonometry terms we're going to learn. Sine, cosine, tangent. You will see these now. You won't really see them much in Algebra 2 or next year. You may, depending on how far they get. But you may see them next year, but you'll definitely see them in pre-calc. So you should know what these are. So these are like your 3 main trig functions: sine, cosine, tangent. Okay. So they give us, if we were trying to find these different answers we're going to be finding, how would we find them? So if you were trying to find sine of A, or the sine of an angle, so the sine of an angle is going to give me some kind of answer. If I was trying to find sine of A, so I would put sine of whatever the angle, let's say angle A is 35 degrees. Sine of 35 degrees would be the measure of the opposite side to that angle over the hypotenuse. So that would be the measure of, so the opposite side from angle A is the side A, and the hypotenuse is side C. So sine of A would be opposite A over the hypotenuse C. Again, if I was trying to find sine of b, I would do the opposite side. So the opposite side to b would be the measure of b, little b, over the hypotenuse c. So when you're trying to find sine of something, it's always going to be the side measure opposite to the angle, then over the hypotenuse, whatever the hypotenuse is measured. Remember, the hypotenuse is the longest side, basically, is your hypotenuse. Okay? Then we have cosine of a. Alright, so let's say we're trying to find cosine of a or b. So cosine of a or cosine of b would be adjacent over hypotenuse. So adjacent is kind of like near it. So for example, if I was trying to do cosine of a, so sine of a, we did the opposite side over the hypotenuse. Cosine of a would be the side closest to a, so side b over the hypotenuse c. Same with cosine of b. Cosine of b would be the side nearest to it, a, over c, over the hypotenuse. So sine of a is opposite over hypotenuse. Cosine of a is adjacent over hypotenuse. Alright? Now finally you have tangent. Tangent is opposite over adjacent. So if I was asked to find tangent of angle A, right? That would be the side opposite to it, A, over the side nearest to it, B. So the side nearest to angle A is B. The side opposite to it is A, so opposite over adjacent. Tangent of B would be opposite over adjacent again. So angle B opposite of B would be little letter b there. And adjacent to B would be little letter A. Alright, and there would actually be numbered measures, and you actually have to find these answers. Alright, so there's a really cool tool that I kind of want to teach. They actually have it in the book to like the side. I'll just go to the next page to do this. But there's a really cool mnemonic to remember how to use these trig functions. It's called, and they have it right over here on the side, right over here. It's called SOHCAHTOA. Okay, that's how you say it. So you have, it's SOH dash SOHCAHTOA. Kind of like when you have Squidward in that one episode of SpongeBob where he's like the superheroes and he goes Krakatoa. It's like SOHCAHTOA. So not Krakatoa, SOHCAHTOA. Sorry, I was trying to pull a little humor in there. So I know trig is not the funnest or easiest, but we're gonna get it down. So how does this become all this stuff you see here? All right. Well, right? So is sine is equal to opposite over hypotenuse, right? Remember, sine. Cosine, right? Cosine, right? C stands for cosine, is equal to adjacent, ADJ, I'm just, instead of writing down adjacent, over hypotenuse. And then TOA, T stands for tangent, equals opposite over adjacent. So hopefully, again, this is how most, it's a nice, easy mnemonic to remember it. So the S stands for sine, opposite over hypotenuse. C stands for cosine, adjacent over hypotenuse. T stands for tangent, and then O, opposite over adjacent. So if you just do it in this order, you'll always remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. SOHCAHTOA. Alright? So when you're doing these, try to keep this in mind. Alright, I'm going to actually erase this now. So we can move on to our first problem, using these trigonometric functions. What are we going to be using all this for? Okay, so the problems on the homework, they're going to ask you to find a lot of sine and cosine. Again, you're not going to have the homework tonight, but on Monday, you're going to have an assignment. They're going to ask you to find like the sine and cosine of like two different angles. Alright? So, express each ratio as a fraction and as a decimal to the nearest hundredth. You can do the nearest tenth, nearest hundredth, doesn't bother me. I'll probably do the nearest hundredth, so that means like 2 decimal places. So it was like 8.3456. You probably do 8.35. And you'll kind of see as I'm doing this. And they kind of do it here. They do the nearest hundredth. See 2 decimal places. All right. So they give you this triangle, right? I don't know if this is super clear. I'm trying to like clear this up. And you also have the book pages. So they tell you to find the sine, tangent, and cosine of P. I don't know why they do it that way. Then the sine of Q, cosine of Q, tangent of Q. Alright, so let's kind of go through this. Alright? So if you were asked to find the sine of P, well, if we go at So sine is opposite over hypotenuse. So this is angle P here, right? So the opposite measure to angle P is 15, and the hypotenuse is 17. So sine of angle P would be 15 over 17, or if you put that in decimal form, would be about 0.88. You know, again, that's to the nearest hundredth. If you wrote that twice in decimal. All right. So now they ask you to find cosine of P. Well, cosine of P would be the side adjacent to P, and then over the hypotenuse. So, cosine adjacent over hypotenuse. So adjacent to P, so the side closest to P would be a measure of 8. The hypotenuse is 17. So cosine of P would be 8 over 17, or about 0.47. Again, they're estimating these because it's the nearest hundredth. All right, now they ask you to find tangent of P. Well, tangent of P is opposite over adjacent. Well, the opposite side to P is 15. The adjacent side to P is 8, so it's 15 over 8, or about 1.88. All right, not too bad, hopefully. Again, so SOHCAHTOA. Always remember that. All right, so now they want you to find sine of Q, cosine of Q, tangent of Q. So now we're going to do Q instead of just P. All right? So we're never actually going to find the sine, cosine, and tangent of R. We're always going to find of the acute angles, so either Q or P. All right, if you notice here, they only want you to find J and K at the bottom here. All right, so let's do, so we're only going to do it with the acute angles, which would be the smaller angles of the right triangle, not the right angle. So, okay, now let's find sine of Q, cosine of Q, tangent of Q. All right, sine of Q, all right, so is equal to, remember, so, opposite over hypotenuse. So Q, the opposite side to Q is 8. The hypotenuse is 17. 8 over 17 would be sine of Q, which would be about 0.47. Cosine of Q would be adjacent over hypotenuse. Whoop, we lost it for a second. So cosine of Q would be adjacent, the side closest to Q is 15 over the hypotenuse 17, would be about 0.88. Again, adjacent over hypotenuse. Then tangent of Q would be opposite over adjacent, TOA, T-O-A, T equals, tangent equals, opposite over adjacent. So opposite would be, so opposite to Q is 8, adjacent to Q is 15, 8 over 15 is about 0.53. That's all you got to do, SOHCAHTOA. Sine, opposite over hypotenuse, so opposite side measure over the hypotenuse. Cosine, the side closest to the angle, adjacent over hypotenuse. Tangent is opposite over adjacent. So tangent is opposite over adjacent. All right, so now we're going to try number 1. I'm actually going to I want to do with you sine of J, cosine of J, tangent of J. I know it's easy with all the colors. I'm going to help you find the first three, then I'm going to have you guys pause, try sine of K, cosine of K, tangent of K. All right? So to give you this picture here, here's the triangle JKL. It's a right triangle. So we're going to use these trigonometric functions to do this. Now, if you're looking to, we're going to have to use these in the 2 problems after this. If your calculator does not have it, they should have sine, cosine, tangent on it. If it does not, you can just look up calculators online. There should be one where you can access and actually use sine, cosine, tangent. All right, so let's write it even down. If you want to write it as you're doing it, let's just write down, so it's up there, but I'm just going to write it, TOA. All right, so before you do these problems, I would try to write this out. All right, so first thing we have find sine of J, cosine of J, tangent of J. So we're looking at this angle here, angle J. All right, so let's find sine of J first. Okay, well sine, we know it's opposite over hypotenuse, right? You don't have to write that every time, I'm just doing this as I'm teaching it. So opposite side measure to J is 5. Hypotenuse of this triangle is 13, just the highest. So that is going to be about, if you wanted to round that to the nearest, it's going to be about 0.38. So sine of J is about 0.38. All right, so let's find cosine of J. So that's going to be so that's going to be adjacent over hypotenuse, right? So that is going to be adjacent. So if angle J is here, the closest side angle J, that's 5 was opposite. The closest one is 12. Hypotenuse is 13. So that's going to be approximately 0.92, right? All right, then we have to find tangent of J. I know my notebook's kind of in the way right now. So tangent, TOA, all right, so we get opposite over adjacent. So opposite is, so it's opposite over adjacent, right? So that would be opposite to J is 5, adjacent to J is 12. So 5 over 12 is going to be approximately 0.42. Again, it's in the nearest hundredths, so 2 decimal places over. Alright, so now I would take a pause really quick. Try to find sine of k, cosine of k, tangent of k. Alright? Alright, so welcome back, guys. Alright, so now let's find, hopefully you took a chance, try to find those three. Well, let's see what we got here. Alright, so now we're looking at angle K. So now we're looking at not J, but K. Again, we're never going to look at the right angle, we're always going to look at the other two. Let's look at K there. Alright, so sine, remember, so if we're doing sine of K, I'm not going to rewrite the whole, you can kind of see it with, so it's opposite over hypotenuse. So opposite to K is 12, the hypotenuse is 13. So sine of K is going to be a 12 over 13, or about 0.92. Alright, and then we got to find cosine of K, right? That's going to be adjacent over hypotenuse. So adjacent, the side closest to K is 5 over the hypotenuse 13. Remember ka, adjacent over hypotenuse, is going to be equal to, sorry guys, approximately 0.38. Alright, so we're seeing the same measures, just it depends on what angle you're looking at. Alright guys, and finally, we're going to have tangent of K, which is going to be opposite, so 12 over adjacent over 5, which is going to be approximately, over 5 is going to be about 2.4. So hopefully you found those. So that's using these trigonometric ratios in order to find use the trigonometric ratios and find cosine, tangent, and sine ratios. So hopefully that wasn't too bad. So TOA, remember that, you will be pretty good. Alright, so now that last section, learn about those special right triangles and what each special right triangle did. You're going to need that for this next part, okay? So it talks about, so example 2 says use special right triangles to find trigonometric ratios, alright? So this is going to be a little bit different. Maybe a little more complicated, but as long as you remember, as long as you look back at the special right triangles, you should be fine. Alright. So, I'm going to do actually both of these with you, okay? So use them as examples. Alright, so it says use a special right triangle to express the tangent of 30 degrees as a fraction as a decimal to the nearest hundredth. Okay, so first off, it says draw and label the side lengths of a 30, 60, 90 right triangle with x as the length of the shortest leg. The side opposite the 30 degree angle has a measure of x. The side adjacent to the 30 degree angle has a measure of x root 3. Okay, so remember, we had a 30, 60, 90, right? So they put the 60 here, the 30 here. So the shortest length gets x, right? Well, that's easy, right? So if the 30 degree, remember we were learning about 30, 60, 90. If you go back to the last section in your homework today, remember, if the 30 degree angle was x, the side across from the 60 degree angle was x times the square root of 3, and then the hypotenuse was 2x. Remember, 590 was 2x. You go back to A3. So remember, 30. If 30 was a side measure, whatever it was, the side across from the 60 was that side measure times the square root of 3. The hypotenuse, so the side across from 90, was always 2 times that measure. Alright, so they want you to find the tangent of 30 degrees, okay? So what they want you to do is, okay, so we're going to use those trigonometric ratios we just talked about. So you're trying to find tangent of 30 degrees. What you're going to do is, you're going to write tangent of 30 degrees, right? Because that's what we're dealing with. Sorry, the degrees on the inside. So you have tangent of 30 degrees is going to be equal to, what did we just talk about? TOA is, I'm going to write it down here, is going to be, they show it here, opposite over adjacent, right? Okay, well, if you're talking about 30 degree, right? The opposite side of the 30 degree is x. Adjacent to the 30 degrees, the side closest to it, is x root 3. That's not the hypotenuse, right? All right, well, if we do this, right, well, x over x, right, because this is multiplied, they show you here the x's are going to cancel. So this becomes 1 over root 3. Remember, we cannot have a square root at the bottom. So in order to get rid of that, we have to multiply top and bottom by that square root, okay? You cannot have it at the bottom. Why do I do that? Well, this becomes root 3. But remember, we talked about in the last section, any square root times itself equals the thing under the square root. So that becomes root 3 over 3. If you want to write that as a decimal, they show you that's approximately 0.58. Now, another way to check this answer, if you use a calculator, like your own calculator, or you use one online, make sure it's in degree mode. But if you type in tangent of 30 degrees, you'll get the decimal, 0.58. About 0.58, it'll probably be 0.58, some, keep going. But I really like to see this part, the root 3 over 3. So even if like on a quiz, I'd ask you for both. So even if you type that in and you find the decimal, doesn't mean you'll get the actual like fraction part of it. But so that's how you do that one. So opposite over adjacent. So you have to actually draw the right triangle, a 30, 60, 90 triangle, or we're about to do a 45, 45, 90 triangle. You have to actually draw the triangle, then, always across from 30, you're going to put your x. Across from 60, you always put x root 3. And across from 90, and you'll put 2x. And then you'll have, this will change, this part, depending on what trig function you're talking about. Alright, guys? Alright, so now let's try number 2 together. I'm going to do number 2 with you guys, and then we'll move on to the last problem I'm going to do today. Alright? And I'm explaining a lot, guys, just know this is very new. Alright, so now they say we have, use a special right triangle to express the cosine of 45 degrees as a fraction and decimal to the nearest hundredth. Okay, so now for number 2, we're dealing with a 45, 45, 90 triangle. So we're going to have the right angle here, and then a 45, 45, 90, remember the other two angles are 45 degrees. So what happens here? So with a 45, 45, 90, the setup's going to be instead of that, right? So remember when we had these, the sides opposite of the 45s were congruent. I'd always make those x. Remember, if you go back, the hypotenuse was always that leg, this measure, times the square root of 2. So that's going to be, when I have a 45, 45, 90, that's going to be my setup every single time. So the setup's always going to be the same, and it just depends on what trig function, everything they're asking you, is what's going to be your answer. It says you want to find cosine of 45 degrees. Doesn't matter which 45 degree angle, because they're both the same measure. So we're going to find cosine of 45 degrees, right? Alright. Cosine of 45 degrees. Alright, well cosine, we know, is we go so that's the C, right? Is going to be opposite over hypotenuse, right? Ca is equal to opposite over hypotenuse, right? So, adjacent, sorry, ca. That's my thing, CAH, adjacent. So adjacent to 45, so the side close to 45 is going to be x. The hypotenuse is x root 2, right? X root 2, the side adjacent is x. They're going to be the same. So what's going to happen here, just kind of like here, the x's are going to cancel. So I'm going to be left with 1 over root 2. And we have to get rid of that root 2 at the bottom. So we're going to get root 2 over 2. Which is going to be approximately, because 1 times root 2 is root 2. Root 2 times root 2, remember any square root times itself is equal to a number under the square root. So we're going to get approximately 0.71. So root 2 over 2 and 0.71, and you see both of those. So, and again, if you type in cosine of 45 degrees, you will get 0.71, some. It's going to go on for a long time decimal. But that's how, so if you're doing 30, 60, 90s, you're going to set it up this way. 45, 45, 90, you're going to set it up this way with the x's. And then it just depends on what trig function they want you to find and what angle they're talking about. Alright? Set it up this way, and then depending on what trig function they're talking about and what angle they're talking about, it's going to depend on what your answer is. Alright? Alright, so that's the first two. We got one more problem to do, guys. Alright. So the next example, they talk about this real life thing. I think it makes it way more confusing. I'm just going to jump right to 3A, and then I'll have you guys try 3B. Alright? So, alright. So let's jump to this last example. So, 3A and 3B, they ask you to find x to the nearest hundredth. Alright. So, now instead of just dealing with special right triangles, just given any other triangle with some acute angle. You're going to deal with that acute angle, and you're going to find x based on whatever you have, okay? So, let's talk about this first one, right? I know the hypotenuse I know the side of the hypotenuse, right? And I know the side adjacent to 25, and I know the side opposite. So this is the hypotenuse here, I'm sorry guys. So the hypotenuse is here, right, that's my hypotenuse. So I know the side adjacent to 25 and the side opposite of 25. So you have to figure out think about what you know. So in that case, think about it. So, ka, toa. The only one, so sine is opposite over hypotenuse. I don't have the hypotenuse. Cosine is adjacent over hypotenuse. I don't have the hypotenuse. But I do have the opposite side and the adjacent side. So think about what you have. So opposite and adjacent, the only one that deals with that is tangent. So how I'm going to do this, I'm going to do tangent of this angle. So tangent of 25 degrees is going to be equal to opposite over adjacent. Okay, so that's going to be, opposite's going to be x, so it's going to be tangent of 25 degrees is going to be equal to opposite x over adjacent 18. Okay, so now to find this answer, what I'm going to do is I'm going to multiply. So remember, I want to get rid of this 18 here. So I'm going to multiply both sides by 18. All right. So I'm going to do 18 times tangent of 25 degrees. I would just type that in a calculator somewhere. What you're going to get, and that's going to equal x. So if I do that, it's going to equal, so I'm going to multiply 18 to both sides. That's all I'm doing. So x is going to equal approximately 18 times tangent of 25 degrees, which is about 8.39. Alright? So all I did was identify the angle I'm looking at, right? It's the one acute angle you're given. And then see kind of what information you're given. So I don't have the hypotenuse, but I have the opposite. I'm looking for the opposite side, and I have the adjacent side. So the only one that deals with opposite over adjacent would be tangent. To tangent of whatever that acute angle is equals, opposite over adjacent, set it up, and then solve for x. Alright? Alright, so now pause real quick and guys try 3B. Alright, welcome back. Alright, hopefully you guys tried 3B on your own. So let's look at it. So we know it's going to be cosine of 70, alright? 70 is the only other angle that's not our, not our acute angle. That's our only acute angle, alright? So let's see what we're dealing with. So x is on the hypotenuse side, so I'm dealing with the hypotenuse. So the only time I know this, I see the hypotenuse at the bottom. Alright, oh, I don't know cosine yet. Sorry guys, I just see what I'm dealing with first. So, I went a little bit ahead of myself. So, I gotta see what I'm dealing with first. So I know I'm dealing with 70, right? I kind of gave it away now. But see, 70, the only sides we know are, we're looking for the hypotenuse, so we know it's going to be a hypotenuse. The only two dealing with the hypotenuse are sine or cosine. Now the side opposite to 70 we don't know. But the only other thing is adjacent to 70 we do know. So what's going to be adjacent over hypotenuse? That's cosine, right? So I'm going to do cosine of 70 degrees, alright, equals adjacent over hypotenuse. So that means cosine of 70 degrees is going to be equal to the side adjacent to it, which is going to be 15 over the hypotenuse, which is x. Alright, now in order to solve for x, I'm going to get the x out of the denominator actually. I'm going to multiply x on both sides, okay? I'm going to get rid of that x. This is going to be cosine of 70 degrees. X equals 15. So the x is still on the outside, it's multiplied by x. So what I'm going to do to find x, I'm going to divide by cosine of 70. So again, you're going to need a calculator for this, no ifs, ands, or buts. So then, x is going to equal 15 over cosine of 70, which can be approximately, again, this is not exact, which can be approximately 43.86. And there you go. So there are my 4 problems, my 3 examples for today. That's your start trigonometry. We'll do the second half of 8.4 on Tuesday next week. You have an assignment on this on Monday. Please email me with any questions. I'm trying to help best I can. I know it's really hard for me to help from a distance by you guys being here live. But just email me. I will try my best to explain it to you. And yeah, your solutions for the other homework yesterday are on there too. So you email me. I have a Google form attached. All you have to do is fill out the Google form. That's your attendance for the day. Monday we'll have an assignment, and we'll move on from there. We'll have a test next Thursday or Friday. I hope you guys have a great weekend and a great Friday, and I will see you guys back here on Monday. Well, you won't see me again until Tuesday, but you guys will be back Monday for an assignment. Have a great Friday weekend.